Lesson 2.6, multiplying nth root radicals. So we've learned about how radicals can have any index, square root, cube root, fourth root. It can keep going, keep going. The first two problems on this will deal with problems that have the same radicals. They're cube roots. And so what happens is when you're multiplying those, there's what's called the product rule radicals. So say I have the nth root, or like the square root of 5 times the square root of 2. What I can do is, since they're both under a common square root, I can simplify that and say it's the square root of 5 times 2, or the square root of 10. But you can only do that if the indexes are the same. So remember, these both have a little imaginary 2 here. So if they were both cube roots, you could do it. If they were both fourth roots, you could do it. So that's what's going to happen on problems 1 and 2. But then 3 through 6 will have different indexes, and we'll treat those a little differently. Okay? So if the radicals have the same index, you actually have two options. Kind of depends on the setup of my problem, which one I pick. You can either simplify your radicals first and then multiply everything, or if you want to multiply first, which might get you a bigger number, but that's okay, then you simplify. If the numbers are super big, I'd probably rather simplify first so I don't have to figure out the perfect cube or square or whatever, or the biggest perfect cube or square to take out. Okay? And then make sure we're using the product rule, which means we're going to add the powers when we're multiplying the exponents. So number 1, we've got the cube root of 25k to the 6th power. I know that 25 is not a perfect cube and it cannot be broken down, so I'll leave it, and 36 is the same. You would think, yeah, it can divide by 3, but that's not what a cube means. Okay, so we'll go ahead and we'll say we're going to multiply this to get the cube root of 25 times 36, which is 900. And then k, we're going to add 6 and 5 because they're really getting multiplied under the radical. So it looks kind of funny. It looks like the word buck, doesn't it? That's cube root of 900, k to the 11th power. And so cube root of 900, let's see if that simplifies. Remember, you hit math. Option number 4 gives you a cube root. It's a decimal. And looking at my sheet of perfect cubes, I don't see. The only one would maybe be 125. That would work. Nope. 64 doesn't work. 27 doesn't work, and 8 doesn't work. So believe it or not, 900 cannot be simplified at all, but I can take some k's out. Okay, so this would be the cube root of 900. Remember, I want to break this into 2, so I go down to k to the 9th power, but then I need 2 more to make that 11, so I need times the cube root of k squared. Oh, I put that backwards. Let me fix that real quick. Okay, I was still thinking 900 was going to be simplified, but it's not. So this is all I can simplify. 9 divided by 3 would be k to the 3rd power comes out times the cube root of 900 k squared. All right, number 2, even though it has parentheses around these, they're still just getting multiplied since they're touching here. So it's exactly the same problem as number 1. Looking at this, I see cube root of 81. Can that be broken down? Doesn't 81 divide by 27? Leave 3 times. Yeah, so on this one, I think I would like to break these apart so I don't have to multiply 81 times 250. That seems excessive. But you could try it if you want to. So I'll break this down into the cube root of 27, then b times the cube root of 3. P to the 6 is a multiple of 3, so it'll stay there. So that would simplify into the cube root of 27 is 3. 6 divided by 3 is 2, so it'd be p squared times the cube root of 3. Okay, let's do the same thing with 250 if we can. Looks like 250 can divide by 125. So So I'll have cube root of 125 times cube root of 2. P to the 7th, I'm going to go down to p to the 6th with a leftover p. That would be cube root of 125 is 5. 6 divided by 3 is p squared times cube root of 2p. And now what you're doing is you're multiplying the things that are out in front of the radicals, and then you're multiplying what's under the radicals. Okay? So we'll take 3 times 5 and p squared times p squared. So 3 times 5 is 15. If I had a p squared times a p squared, that's p to the 4th because you add them. And then I'm taking cube root of 3 times cube root of 2p. So think about if you multiplied 3 times 2p, that would get 6p. So it's 15 p to the 4th cube root of 6p. All right, second set. We talked about how we have different indexes. If you look up here, you have to simplify the radicals first. You cannot multiply if they're not the same radical. Any leftover variables, you need to write as a fractional exponent, and then we'll combine. All right, so the first one is square root of 4, which would be a 2. This would be 12 divided by 2, which would get x to the 6th power, times the 4th root of 81. That is a perfect 4th. That is 3. And then 4 divided by 4 is 1, so just x. So this is really nice. You can just simply multiply. 3 times 2 is 6. X to the 6th times another x would make x to the 7th. Okay, so I'm going to pause and let you try number 4. You should have gotten 36x to the 7th. Everything was a perfect 4th and square, and all the exponents came out nice and neat. So 36x to the 7th. All right, number 5. We have a square root of 64, which I know is 8. Square root of x to the 9th. 9th is odd. So what I would do is, yeah, you could go on and break these up, but the faster thing is going to be to make this 9 halves. This is x to the 9 halves power. That 2 came from this as an index. 9 over 2. Times 4th root of 256. I feel like that's on our sheet. It is 4. And then 10/4 is my power. Anything I can reduce, I have to do that. So first I've got, what, 8 times 4 is 32. X to the 9 halves times x to the, divided by 2, that'd be 5 halves. And what is our rule when we multiply exponents? We add the power. So you're adding 9 halves plus 5 halves, which is 14 halves. And 14 divided by 2 is actually just 7. So it's 32x to the 7th power. Still comes out nice. Just takes a little work. All right, number 6, if you want to pause it, you can, or stay with me. 4th root of 81, we've had this several times, that's 3. This would be x to the 10/4 times square root of 121, 11. X to the 1/2, right? Square root was the 1/2 power. 3 times 11 is 33. 10/4 reduces down to 5 halves times x to the 1/2. Multiply straight across, or I mean not multiply, I'm on autopilot right now. Add, right, because we're multiplying. That would be 5 plus 1 is 6 halves. Oh my goodness. Which is 6 divided by 2 is just 3. So it's 33x cubed.